Artificial intelligence is a term most of us used to see in science fiction movies. I remember as a kid, I used to spend hours in front of my TV watching movies like The Matrix, Red Planet, and Minority Report. Those movies showed us that computers could think, robots acted like people, and the future was as exciting as it was scary. Well, that future is now. Today, artificial intelligence isn't just something we see in movies. It's something that's part of our daily life. It's in all sorts of businesses, and it's changing the way we do things. Many years ago, computers were clunky and as big as an entire room. They were extremely slow and could not perform some of the simplest tasks we do today on a smartphone. But scientists started asking questions. They started entertaining the idea that maybe one day machines would be able to think and perform tasks by mimicking human intelligence, or maybe become smarter than humans. Modern computers and the groundwork for artificial intelligence can be traced back to the urgency of the Cold War. In 1945, a scientist named Vannevar Bush wrote an amazing article titled As We May Think, which was published in the Atlantic Monthly. In that article, he introduced a conceptual device called the Memex. The Memex was a theoretical machine designed to store and retrieve vast amounts of information. Some people called it an early concept of a personal computer. This idea was the initial spark that was needed to inspire other scientists and visionaries, and one of them was Doug Engelbart, who, in some ways, would later set the technological foundation for a lot of what we all enjoy today. In the 1950s, the Cold War between the United States and the Soviet Union reached its peak. The fear of potential enemy attacks led both nations to prioritize air defense systems. The United States devoted significant amount of resources to develop what is known as the Semi-Automatic Ground Environment System, also known as SAGE for short. The SAGE system used early computers with displays to process and present radar data, paving the way for the groundbreaking TX2 machine and the Sketchpad system, which we'll dive into later. Back then, the concept of machine intelligence was still in its infancy. Way before the Cold War, way before the Memex device, researchers like the British mathematician Alan Turing had started to explore the possibility of creating intelligent machines. As early as the 1930s, he introduced the concept of universal machine, which is also known as the Turing machine. His research was the beginning stage of theoretical computer science, algorithms, and computation. But there was one big problem. There wasn't really any field of study that focused on artificial intelligence at the time. In 1950, he famously developed the Turing test, which is a method to determine if a machine possesses characteristics of human-level intelligence. In 1955, the very first artificial intelligence program was simulated by Alan Newell, Cliff Shaw, and Herbert Simon. The AI program was called the Logic Theorist, and its primary purpose was to mimic human problem-solving skills. It was built on a computer known as the Joniac computer from the Rand Corporation. In 1956, a major event took place. The Dartmouth Summer Research Project, organized by John McCarthy. It was during that time the term artificial intelligence was first used by John McCarthy and accepted as a field of study. John McCarthy proposed the conference and stated that it was to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. It's important to note that although Alan Newell, Cliff Shaw, and Herbert Simon started working on the Logic Theorist in 1955, it was first revealed to the public at the Dartmouth Conference in 1956. Right after the Logic Theorist, another AI program was developed, this time by a scientist named Arthur Samuels, and it was called the Checkers Playing Program. In 1958, scientists at MIT built the TX2 machine, a cutting-edge digital computer that featured a graphic display and real-time user interaction for the very first time. It was the successor of an earlier version called the TX0, Transistorized Experimental Computer Zero. This technological marvel was years ahead of its time. It represented a quantum leap forward in computer technology. The TX2 machine would serve as the foundation for the revolutionary Sketchpad system, which forever changed the way we interact with computers. Although the TX2 was groundbreaking, it was way too big. It was the size of a house. In 1963, 5 years after the TX2 machine became operational, Ivan Sutherland, a computer scientist at MIT, developed a computer program called Sketchpad, which would take advantage of the screen of the TX2 machine to make it more interactive. This was possible because of how good the TX2 machine was at the time. The Sketchpad system was the first computer program in history to use icons on a display, allowing users to interact directly with objects on the screen through a pen, a light pen to be precise. This was when everything in human-computer interaction completely changed, and it laid the groundwork for modern graphical user interfaces, also known as GUIs. The Sketchpad system redefined technology, but it also ignited the personal computer revolution. Let's rewind a bit. You remember in the beginning of the video I mentioned the article As We May Think, written by Vannevar Bush? That article had a profound impact on a 20-year-old Doug Engelbart. He read the article in 1945 and was fascinated by the concept of the Memex device. Engelbart would later dedicate his life to the advancement of computer technology and human-computer interaction. In the 1960s, Engelbart received funding from the Advanced Research Project Agency, ARPA, which is now called the Defense Advanced Research Projects Agency, DARPA. The launch of the very first satellite by the Soviet Union in 1957 was a wake-up call for the United States. As a result, the US developed ARPA, which focused on breakthrough technologies for national security. With ARPA's support, Engelbart is known for some amazing achievements: the development of hypertext and real-time collaboration systems. He's the one who invented the computer mouse that we all use today. These innovations would go on to revolutionize the way we work, communicate, and interact with technology, forever changing the world of computing. In the mid-60s, artificial intelligence was still a fairly new concept, but it set the precedent for ideas that sound like sci-fi movies. In 1965, Irving Good presented the idea of intelligence explosion, or the singularity. According to Good, if machines could improve their own designs, they would undergo a rapid cycle of self-improvement, leading to super-intelligent machines that would go far beyond human intelligence. Since then, this idea has been the main focus in conversations related to AI and machine learning. In 1966, Joseph Weizenbaum, a computer scientist from MIT, announced ELIZA, the first computer chatbot simulating conversations with humans. The chatbot was basic, but some users were still convinced that it had feelings just like a human. In the 70s, interest in AI started to decline, and less funding was allocated to research and development. This was known as the AI winter, but development in AI was still ongoing despite those challenges. Scientists at Stanford University managed to build the Stanford Cart. It was one of the first robots to navigate autonomously using computer vision. The project was led by James Adams at Stanford University in the late 60s. It was initially designed to be a lunar rover, hence Moravec upgraded it in the late 70s to use computer vision to autonomously navigate cluttered spaces by using the images obtained from an onboard camera system. The Stanford Cart was extremely slow. It would take hours to move just a few meters. It was, however, an important predecessor to the advanced autonomous systems we see in today's society. It served as a great contribution to the field of robotics, more precisely in autonomous navigation and machine perception. The AI winter eventually ended. In the 80s, we saw a lot more research and interest in artificial intelligence again. This was driven by Japan's Ministry of International Trade and Industry, which initiated the 5th generation computer systems project in 1982. The intent was to create machines capable of carrying out tasks associated with human intelligence. Unfortunately, it did not achieve its goals. The 90s were some important years in AI development. In 1997, IBM's Deep Blue, a chess-playing computer, achieved the impossible. It defeated the world chess champion, Garry Kasparov. A machine winning a chess game against the champion was a groundbreaking moment in AI history. It was a glimpse into the future. Machines outperforming the smartest humans in intellectual tasks. It was also in the 90s that we started seeing the emergence of machine learning techniques. People feed the computer data, and it learns and makes decisions by itself. In the 2000s, the field of artificial intelligence was experiencing some important transformation. A subset of machine learning emerged, deep learning. Deep learning mimics the structure and function of the human brain and uses artificial neural networks to model and understand complex patterns and data. Deep learning is extremely important in AI. By using deep learning to process large data sets, tech companies achieved speech recognition to natural language understanding in the recommendation systems. Tech giants such as Google, Amazon, and Microsoft started to invest heavily in AI and machine learning, integrating these technologies into their products and services. Apple released Siri in 2011. Google released Google Now in 2012. It later became Google Assistant. Microsoft announced Cortana in 2014. In 2009, Google initiated a self-driving car project named Waymo. The belief was by taking the wheel out of human hands, self-driving cars would drastically reduce accidents caused by human error. In other terms, it would revolutionize transportation. Around that time, IBM was making significant progress on their system called Watson. Watson is an AI system capable of answering questions posed in natural language. IBM defines it as a computer running software called DeepQA. Its purpose was to win on the TV show Jeopardy, and to ultimately create a new generation of technology that could find answers in unstructured data more effectively than standard search technology. In 2011, IBM's Watson competed against two of Jeopardy's top champions and won. 2012 was also an important year in deep learning. A team from the University of Toronto submitted an AI model for the ImageNet competition, a contest in image classification and object detection. The model, named AlexNet, significantly outperformed all traditional methods. This was significant because it showed the potential of deep learning. This event was considered as the catalyst for the AI boom we see today. Deep learning is now applied in so many sectors, such as healthcare to entertainment and finance. In 2013, smartphones got a lot smarter. The voice assistant on the iPhone, Siri, had been around for a couple of years, and it received a major upgrade. Siri became more conversational and less robotic. It started to respond to users' commands with a little bit more clarity, thanks to natural language processing.
The voice of Siri, and we've got an all-new voice.
Hi, Eddie. What can I do for you?
Also in 2013, a startup called DeepMind unveiled a neural network that learned how to play video games. The AI learned just from pixel inputs, just like humans would play. Google later acquired DeepMind for about $500 million.